so when we talk about solutions to a quadratic equation, when you graph that, it's where it's going to cross the x-axis, because where it crosses the x-axis, the value of y is 0, and that's how you solve the quadratic. So the solution crosses the x-axis or intersects the x-axis, and that's where your value of y is 0. These are also going to be called or referred to as the zeros, because the y value is 0. Then also the roots. If I tell you to find the roots, I'm asking you to set it equal to 0 and solve. That'll make more sense soon. Or we could just call it the x-intercept. Using any of those terms, I'm talking about the same things. The zeros of the graph, the roots of the graph, the solutions to the graph, x-intercept. It's all meaning to do the same thing. When you graph a quadratic and you solve this in Desmos, it'll make that parabola, whether it's going up or going down. If it has two solutions, that means it's crossing the x-axis twice. It'll look something like that. It can also be upside down and going down. You could flip that up, but it crosses right at the x-axis. And right here would be the two solutions. So there would be two values for x to make that equation equal 0, or expression equal to 0. If there's only one solution, that means that your parabola is going to sit on the x-axis. So there's only one. We could also have it going the other way, of course. And we saw that a little bit with the marble slides of the Desmos. If you got that far, you might have had to flip that parabola upside down by making that first value or the a value negative. If it doesn't cross the graph at all, so it looks something like this, that means there's no real solutions, and that's where we get into the imaginary number system. The imaginary number system has an application, and when you look at computer programming and all of that. So we've been in the real number solution up to now, and you're going to see what we call the roots or the solutions to this. And they are in the imaginary system because they don't truly exist. But for computers and solving things, we have to have that number system in there. Everybody okay so far? All right. For the next part, we could make tables and all of that. Well, let's start out doing it that way. When we find the solutions, actually, let's graph. Go and get your computers out. I want you to see what it looks like, and then we'll show how to put it on there. Go ahead and get your computers. Is x is equal to negative b over 2a. This is for your vertex. That's the x coordinate you're looking for. Negative b over 2a, and I'll explain what that negative b and a refers to. In the last unit, we talked about how this is in the form of ax squared plus bx plus c. So your a and b term is what you're going to pull to put into the vertex equation. In this formula, what is my b value? 2. Very good. So my x is equal to negative 2. What is my a value? 1. Very good. So coefficient of x squared. And then you calculate that out. Hopefully you can do that in your head. What is negative 2 divided by 2 times 1? Negative 1. Very good. So that means that your vertex on your graph is at negative 1. So the first thing I would want you to do is to draw a dashed line at x equals negative 1. And that shows where that parabola is getting split in half. And it'll mirror itself on either side. It's almost like the line of reflection from geometry. And then we're going to go ahead and state that this is x equals negative 1. And then you're going to make a table. Let's do x, y. We're going to do 5 values on the table. The middle value is going to be, let me give myself more room here. The middle value is going to be your vertex. X, y. So right in the middle, put negative 1. To determine what other x values you have, you're going to go up 1 and down 1. It doesn't matter which one are the lower values. I always make the lower values on top. So I'm going to go down 1, so negative 2, down 1 more. And then you can go up. So 0, and then 1. So at the vertex, we're basically going out on the graph. We're going to graph where 0 is and what 1 is. And we're going to graph what negative 2 and negative 3 is. Everybody okay so far? Okay. figure out what our y values are. So in your calculators, you can borrow my red ones. We're going to put -3 in for each of the x's, figure out what the y value is. Then we're going to put -2 in for each of the x's, figure out what the y value is, and so on and so forth. So for -3, you have -3 in parentheses squared plus 2 times -3 minus 3. It'd be +9 minus 6 minus 3. Make sure that this is in parentheses, because when you square -3, it should be a positive.
I have to square it always.
+9 minus 6 minus 3. And what would your y value be?
When you're multiplying that 2 by the -3, would that be negative?
Yes.
Oh.
0. Very good.
Oh.
So -3, 0. We're going to do it again, but now you're going to put a -2 in. And in your calculator, you can hit the up arrow and then go back and just replace the -3 with -2 if that's easier for you. -2 squared plus 2 times -2 minus 3. +4 minus 4 minus 3. -3, good. We'll do the same thing, but now with -1. What'd you get? -3. Not -3, close. -4, yeah. If you're having trouble getting these in your calculator, you can certainly ask for help. Now we're going to put a 0 in, so 0 squared plus 2 times 0 minus 3 should be, this was easy, -3, right? Now do the same thing for 1. Zero, yep. So what do you guys notice with this table? It mirrors, exactly. So right at the vertex, you should see the same values on either side. As long as you only went out 1 on either side of the vertex and went out 2 on either side. If we went out 3 on either side, added or subtracted, you get, again, the same one, because it mirrors itself.
What are you talking about mirroring? Where is it mirroring itself? Oh, I thought you were talking about both sides.
Oh, yeah, no, I'm splitting it this way. All right, let's go ahead and graph those. We have -1, -4. And I know that's the vertex, so that's right where it's going to change directions.
So instead of starting on that big old line, you're starting on the dotted line.
Because I already know that's -1 and -4. So I graphed that. And then we're going to do -2, -3. And if you want to go ahead and do what it mirrors, you can do that at the same time. And then -3 is 0. And 1. From here, again, I want 5 points for each of these graphs. You're going to sketch in the parabola. Make sure you hit the points you graph. We could go out 1 more and make it more exact, but that's enough for our purposes as long as you cross that x-axis.
It's the first problem.
This is not going to go well. So here's your vertex. And then right here, where it's going, or it equals 0, those are your roots or your solutions to that equation.
Yeah, I figured out that's not what do it for me.
Right, you're going to check your answer. You're not always going to have to have those for the test. You do have to know how to do it by hand. Alright, so then the solutions, again, what I just said, your solutions are -3 and 1 because that's where it's crossing the x-axis. So you would put for your solutions those fancy brackets, and then -3, comma 1, and then the fancy brackets to end it. Just make squiggly lines. That's what I mean. You don't like the graphing?
I like everything else but the graphing part.
There's only one section of one other. No, that's a lie. I think we do this a few times. Right, you guys want to try it again?
Yeah.
Alright. So again, we need to start out with this x equals negative b over 2a. What is my b value at number 2? Very good. So the equation has negative, and then we have negative 10. So that's going to become positive. What is my a value?
Oh, wait. 1.
It'd be negative 1.
Oh, yeah.
How do you get that? From the ax squared plus bx plus c is the standard form. So your coefficients of your middle term is your b term. Coefficients of your x squared term is your a term. So negative 1 and negative 10, they plugged it into the negative b over 2.
What's that coefficient?
Coefficient is the big number next to the variable.
Okay.
What is negative 10 divided by 2 times negative 1? Negative 10. Close, but we have 3 negatives in there, so it's stay negative. So these become positive, and you have a negative there. So then you're going to graph your line of vertex. So 1, 2, 3, 4, 5. Put a dotted line. Mark it x equals negative 5. We're going to use that to start to build our table. So you have the x and y. Right in the middle, put negative 5.
What do you do if it's
With the what?
25?
No, for now, nothing. When we start plugging it in, then it'll change our answers.
Okay.
And then we're going to go down 1, down 2, and then up 1, up 2. Now on your own, start plugging in these values to get the y values, just like we did before. Start plugging in your x's to get your y's.
So would you put a negative 7 or a positive 7?
Oh, good question. We're going to do this one with you. You want to do the first one? All right, so it's negative 7 squared. What's that?
Oh, so negative?
Yep, so minus 10 times negative 7 minus 25. Because that's like having a negative 1 coefficient.